So in this lesson, we're going to talk about vectors. And if you've watched Despicable Me ever, you may remember the character Vector. And in the movie, he says, my name is Vector because I'm committing crimes with both magnitude and direction. Oh, yeah. So his magnitude and direction, you probably never caught that before, but obviously as a math person, I have. That is actually what a vector is. It is a kind of looks like an arrow. I'm going to show you a picture, but it is measured in both magnitude and direction. And so the reason that we would talk about them having both magnitude and direction is that they have a size related to them. That's what magnitude means. It says magnitude here is the length, so we need to make sure we write that down, and it is written in this format. A lot of times it's actually written, I see it more often written with 2 bars, but it means the same thing. All right, so this is magnitude. And then the direction would indicate not just maybe if we're thinking about force. A lot of times in science, we use vectors not to just talk about how strong something is pushing, but also the direction that that is coming from. So a few notes to make about those. So direction is measured by degrees, usually from 0. So one thing that I need for you to draw in your notes, you've never really learned about this, and you don't necessarily need to know other than this one thing. If you've ever paid attention to how they count quadrants, they count them starting in that upper left, and then they move counterclockwise. Degrees are measured that same way. So it is important that you note that 0 degrees is over here on the left. Degrees are measured moving counterclockwise, so 90 degrees would be up here at the top. And for instance, 200 degrees would be over here in the third quadrant, right? You'd be moving around the circle a little bit past 180. And then magnitude is a measure of distance. And so if you have Ms. Sharp, she should have drilled into your head, and I know she did, about 15 times last year, that distance is measured easiest by Pythagorean theorem. All right, and then lastly, you need to draw this out. This is what a vector looks like, and it is notated as A, and it's got this little like line with part of an arrow above it. And so this is what you will see when we talk about them. All right, so if you take a second to read this problem, the book has already drawn out a picture for us, and we can call this example 1. In this picture, the 400, actually this what's in red here, this is the plane's path. And the 400 would be the component coming from the engine. And the direction going to the east here, this would be the wind, or the force of the wind that's being applied. So a plane is trying to fly north, but as the wind is being applied, it is pushing the plane further east. All right, so we have this red line actually showing the plane's path. So when we try to name this vector, vectors are named in what is called component form. And you can see down here at the bottom, they are written with these little like angled brackets. So this specific vector, if we want to name it in its component form, so label that in your notes, we're going to do like the x component first, so that would be 90, and then the y component second, which would be 400. And just like we did with matrices, vector components can be labeled in matrices form, where this would be 90 and 400. So these are called component form. And then we can use all of this to actually calculate the magnitude and direction. So magnitude is going to be the easiest thing to calculate. And as I said, we're going to calculate that using Pythagorean theorem. So in this instance, we're just going to use the 2 components of the vector, 90 squared plus 400 squared equals c squared. And we can use a calculator to work that out. And when I did that, I got that the magnitude in this instance was 410. Would be the magnitude. And I guess the better way to notate that would be with that format that I just showed you. Okay. And then the direction can be found using tangent, like I said. So remember, tangent helps us find is opposite over hypotenuse. So tangent, which of the angle we're looking for, is the opposite. And I'm looking, in this case, I'm actually going to look at this angle of how far over the plane was pushed from its northern path. So I'm going to do tangent of 90 over 400. And remember, when we're trying to find this quantity that's stuck inside the tangent function, sorry, my pen's not working, we can do tangent inverse that will help us find that theta value. So tangent inverse of 90 over 400, which in our calculator is going to give us 12.7 degrees. Now, this is being pushed 12.7 degrees east of north. So we're going to do some more tomorrow where I'll help you kind of figure out exactly where we should be looking to use those degrees. All right, so now that we know how to measure vectors, let's talk about addition, and then we're going to talk about subtraction and scalar multiplication. Arithmetically, these are all pretty simple. I do want to talk to you real quick about what they look like on a graph. So notice just how to graph vector v in general. This says 4, 8. So we're going to start at the origin down here. And this vector is going over 4, up 8. So notice the vector has an initial point at 0, 0. Its terminal point is at 4, 8. And it's just drawn as kind of an arrow that direction. Then we have vector, blue is correct. Vector 3, negative 6. So that is going to be this vector that is here in blue. It's going over 3, but it's going down 6. That's vector W. And when we add, we're going to put vectors together. So I'm going to highlight this with a green highlighter. I'll do green. This is vector V. And when I add vector W to it, I put it like in succession with one another. So head end to tail end. And so the resulting vector is going to be this vector down here, VW. And you may notice that VW in vector form, the sum of them, is going to be 7, 2. Now, if you look at the original problem, the x component of the v vector 4, if you add the x components together, 4 plus 3 is 7. And if you add the y components together, 6 plus negative 8, or sorry, I said that backwards, 8 plus negative 6 is going to be 2. So we're going to note that vector subtraction actually works very similarly. If I subtract the vector 6, 2 minus the vector 0, negative 4, we can assume or guess that this answer is probably going to be 6, and then 2 minus negative 4 would give me another 6. Graphically, when we look at, we're going to see two things. So the first thing I want you to recognize is that this is now negative W. So negative W is a vector, and so you should write this down, is a vector with the same magnitude but opposite direction. So notice what I have highlighted right here is W, and so negative W is just going to go, basically it's the same length, but it's going to go the exact opposite direction, so 180 degrees. Then we can add that head to tail just like we did the last one, and you will see that this resulting vector ends at this terminal point 6, 6, just as we expected it to based on our arithmetic. Okay, so the last thing we need to talk about is scalar multiplication of vectors, and I've got two examples to show you here. The first is just what it looks like. So notice that they've given me a vector and they've scaled it by 5. So the original vector is right here highlighted in yellow, and this new vector, I'll use a red marker, is going to be that same direction, but it's just going to be like 5 times the length. So if you saw this, it would be 5 times the original vector in its length. So in your notes, go ahead and record for yourself. 5 times this vector is exactly what you would expect to be, just like with scalar multiplication of matrices. You just multiply the components. The direction you should expect to stay the same, but the magnitude is going to end up being 5 times the original magnitude. Okay, so let's look at another one. In this example, we have a vector right here, s, which is 4, 5, and the scalar multiplication is negative 3. So a few things are going to happen here. In terms of multiplication, you can go ahead and record the vector. The new component vector is going to be what we would expect. We're going to distribute that negative 3 and get negative 12, negative 15. When we look at magnitude and direction, so notice magnitude, the original magnitude here using Pythagorean theorem was 6.4. The new magnitude is 19.2. And so if you multiply, this is just a scale of 3 multiplying the original magnitude by the new one. However, because there is a negative involved, that means we're going to be changing direction. And again, we're going to be using tangent, so it might be helpful for you to write down these numbers right here. The original direction was at 51.3. So this right here was originally 51.3 degrees, and I would note that in your diagram. The new vector has a direction of 231.3. So that is now this direction, 231.3. And what you should notice is that is a reflection, but it is adding 180 degrees to the original because we're reflecting and going the other direction. So for this instance, we would say both magnitude and direction have changed as a result of this scalar. And so that's our lesson on vectors, and we will practice these skills together in class tomorrow.